Good day to all of you viewers. This video is about the laboratory activity number 4, titled Laboratory Experiment on the Basic Circuit, Part 1. First, let's copy the circuit diagram figure number 1. As you can observe, since there's no resistor, the LED only takes a blink of an eye to power up and then burn out, meaning this LED is now gone. First, let's measure the voltage across the LED, even though it already burned out. Since there's no resistor to resist the flow of current or cause of voltage drop, since there's only one electrical component, the voltage of the LED is the same as the voltage of the battery. Now let's see if there's current that goes into the LED. Since this multimeter does not measure current, it's just a different one. Using the multimeter, we observed that there appears to be no current that flows into the LED. Since this one is already burned out, let's use a different LED. Now let's try figure number 2. Which the material that we will use is the 9 volts battery, 1 kilo ohms, and LED. One kilo ohms is about proof that this is a 1 kilo ohms resistor. can observe, it seems using only a 1 kilo ohms resistor. The brightness of the LED is very bright. Now let's measure the voltage across the resistor. The voltage across the resistor is 6.42 volts. Now let's test the voltage across the LED. The voltage across the LED appears to be 2.85 volts. Now, let's measure the current that flows into the positive terminal of the battery to the resistor. To measure it, let's connect the red test tube to the positive terminal of the battery, and then dark colored red tube to the resistor. It seems that the current that flows from the positive terminal of the battery to the resistor is 6.32 milliamps. Now let's see. Let's use the multimeter to measure the current that flows from the LED to the negative terminal of the battery. It seems that the current that flows from the negative terminal of the LED to the negative terminal of the battery is also 6.33 milliamps. figure number 3, we will only change the resistor from 1 kilo ohms to 100 kilo ohms. We will only change it to 100 ohms. Here. Now let's test if it is truly a 100 ohms resistor. The resistor color band is brown, black, brown. From the multimeter, it is truly a 100 ohms resistor. Now let's add it. From what we can observe, it seems that the LED is brighter than the previous circuit, where the one that we use is a 10 kilo ohms resistor. Now let's test for the voltage of the across the resistor. The voltage across the resistor appears to be 5.20 volts. Now let's test for the voltage of the LED. The voltage that goes through the LED appears to be 3.28 volts at 3.27 volts. Now let's measure the current. The same procedure, we will attach the red colored test tube to the positive terminal of the battery and the black colored test tube to the resistor. It seems that the current that passes through it seems that the current that flows through the resistor from the negative terminal to battery, positive terminal to battery to the resistor is 51.8 milliamps. Now let's test for the resistor that let's test for the current, the negative terminal of LED to the negative terminal of the battery. It seems that the current that passes through that flows out from the LED to the negative terminal of the battery is about 50.7 milliamps. That is all. Thank you.